Thanks for having me. My name is Gilles Allain. I'm co-founder and CEO of a company called DeepHawk. And DeepHawk is working on the next generation AI, and it is applied to visual quality control in the manufacturing industry. Non-quality in manufacturing is a huge problem. It's a huge issue. It's about 5% of the revenue. Total revenue is 44 trillion worldwide. So we're talking about a major pain point. And one of the ways to reduce that pain point is visual quality control. And we see three kinds at the moment. One is the human inspection, which has been done for decades. It's expensive, it's slow, and it's actually missing quite a lot of defects. And then about 30 years ago, started non-AI based solution. So solutions that are based on computer vision, but they didn't have AI at the time. You have a lot of vendors. This is a typical machine you see in the middle of the screen here. And those machines are quite expensive, and they're a bit slow to program and also not too flexible to new changes of products. And it applies mostly to certain form factors, so like electronic boards, so you cannot do any kind of product. You cannot do mechanical pieces and so on. And as you know, AI has been the buzzword for a few years now, and the whole industry is expecting a lot from AI, and the industry is expecting AI to solve this problem and to have very smooth and effective visual quality control. But the paradigm actually is wrong for most of our competitors, and it's mostly failing. And for some very well-identified reason. First of all, most of them are learning from OK products. So when you want to detect anomalies on your products, you have to anticipate all of them, and you have to produce enough products to have wrong products, not OK products. And then you have to document all those defects, and you have to have the pictures, and you have to tag the pictures. It takes a lot of time. So basically, it's a deep learning based solution based on huge efforts, gathering a lot of data. The training is slow. I'll get back to that. And usually you need some AI people on your team. And most of the time it's cloud-based. So it's slow. You have to send all the data. And industry players, they don't want to send industrial designs, or they don't want to send information about volume and quality. So basically, the market is substantially unrealized by AI today. And this is where DeepHawk is coming with the paradigm that we are learning from OK products. Very few sets of pictures, 30 to 50 images of OK products. And we fully run on the edge, both for the training and for the inference. So the principles are you have your products on your production line, like could be electronic boards, could be mechanical parts. And then you have a capture system, can be in the visual, can be other types. And then DeepHawk is a software piece only. It's very flexible. We can get any type of camera, any size of objects. And then we analyze the image, and we tell whether the product is okay or not okay. The main benefits of DeepHawk is that it's very flexible first. So you can do any products. There's no limitation in size. We don't have any hardware attached to our software. We can work with any type of hardware. So basically, we can do any product from a few micrometers, if we're using microscopes, to very big products. We can do infrared. We can do X-ray images. We can do both still and video images. And another type of flexibility is that we do incremental learning. So our AI is able to learn a little bit more about something. We don't have to redo the training. So it's basically a plug and play, whether you have the camera or not. We just bring this software piece, the DeepHawk Cognitive Agent, and then we connect to the capture piece, which is a camera or X-ray cabin or endoscope or microscopes or just a normal $300 camera. And then we connect with your IT so that we give the response, whether it's okay with some metadata associated to it. The second benefit for the industrial players is the speed. We learn 1,000 times faster than others, and we respond in 15 milliseconds. So we can do 60 products per second. Accuracy is very high. We have a pixel level detection. we can detect a pixel which would be wrong on your capture system. We have a very high detection rate, and we're doing a test with our clients, so we keep that number very, very close to 100%. Very robust solution versus noise, any type of noise like, any illuminations, any reflections of light, and that kind of things. And because we're not learning any defects, we can detect all of them. Basically, anything which is not normal is flagged as a defect. Last but not least, it's very secure, fully on the edge, fully on-prem, no critical data leaving to the cloud. What I'd like to add also on this is that this is an AI which is a part of what we call the frugal AI. So meaning an AI which is using very limited resources in terms of storage or computing power. We calculated that compared to a plain deep learning solution, we are reducing the carbon footprint by a ratio of 375. This is the example why we claim we are 1,000 times faster than others. Others would take 3 weeks, even some 2 months to go into production, because they have to produce the parts, they have to sort the faulty ones, they have to tag the pictures, and they have to do the actual learning. What we do with only 30 to 50 images is that we do it in 30 minutes, no faulty parts, no sorting needed, no tagging, and a very fast learning. In terms of deployment, the core of our technology is deployed on a very off-the-shelf hardware, no need for huge capacity in terms of computing power or storage. Could be like a Jetson. And then we deploy the DeepHawk cognitive agent as many times as needed next to the camera. And then we have just a management system and then a repository, which is outside of the client premises, which is for the software updates and controlling the licenses. So everything, all the useful data is staying inside. Nothing is going out. Actually, the connection can be open only like 3 days a year or something. We don't need to keep the connection open. In terms of application, we do all kind of products. We do discrete, we do continuous like textile or metal, we do bulk, and we do packaging, especially for food. The initial focus of the company, because the company is new, is the discrete side, and within discrete, it's mostly electronic boards and mechanical products. That's our key focus for the next 2 years. Then I'd like to share a few examples of what we can detect. So on the electronic board side, electronic products, you have the problem of the pins, which needs to be detected early enough so it doesn't go to the soldering. It's detected before, otherwise it's a loss of time and efforts and money, basically. We check the cabling, we check missing cabling or wrongly positioned cabling. Other example here, this is an X-ray image of a piece where we can detect problems that happens during the manufacturing of that piece, missing components, wrongly connected cables for some mechanical parts. So this would be in the visual side. A lot of surfaces control as well. Even very, very, very difficult things to spot for a machine, but we will detect them. So this is leather here on the bottom left, or wood, or marble. So we can detect problems that are actually fairly spread, or very tiny and very clearly located issues here. In terms of sources, so we are running currently, we are running paid prototypes, and the product is going to be actually launched at the end of this month of March. Clients we're working with, so you have people who are doing just visual cameras, IP cameras, industrial cameras. We can work with any brand. Flat panels, that would be for the X-ray, and we have a prototype currently with a major automotive manufacturer, and they are controlling mechanical parts which are actually connected with the wheels of the car. Parts that have a very high requirements in terms of quality. We do still images, we do video images as well. We are supporting multi-view from multiple cameras. It's an example here for 3 cameras, but we have also live prototypes with 4 cameras and 6 cameras. Endoscope controls, that's especially very useful for plain engine manufacturers. Microscopic would apply, for instance, to semiconductors. the infrared to any piece that where you have some element to control in terms of temperature. Now the question is, how would you want to test if you want to check that our promise is solid and then we can deliver? Well, it's a very easy way to test DeepHawk. Actually, you don't need to install any specific hardware. You don't need to spend too much time. Basically, as a client, as a potential client, you can prepare two sets of images. One would be the training set, so 30 to 50 images of an OK product. And another one would be a test set, anything from 10 to 500 or even 1,000 images if you'd like. And that would be random pictures of OK and not OK products. And basically, we come to your premises, or we can do it online also through a video call. And we do the training. It takes maximum 30 minutes. And then we run the test on those images. So we can test about 60 images per second. So it goes very quickly. So this is the way we do the first step with our client. The second step can be directly to go to production or to build a prototype for some specific cases. And we'd love to hear from you, and you can ping us on contact@deephawk.ai, or you can ping either me or Thomas, who is also co-founder and CTO, on the emails that you see here. I'll be delighted to take any questions you have.
Thank you.